Hello, everyone. So we're here to present you and talk about the logistics and the interface between the plant logistic and manufacturing, talking about how to connect the WMS software with the MES software and make sure that we can select the appropriate software to interface with assembly process or industrial process together with the warehouse and all the storage functionalities. My name is Matthew Thoreau. I'm the VP Vice President of Sales for Viasto in North America. And we got Marcus Müllerchen with us as well. Marcus, why don't you introduce yourself?
Yeah, hello together. My name is Marcus Müllerchen. I'm the Vice President Sales of the Viasto software company located in Germany.
All right, so a few words about the market trends. I think, globally, we're all aware of the global trends of, shortage in qualified personnel that we experience in both industry and warehouse management. We start having cost pressure. The customer requirements are changing with smaller batch size, shorter production times. That's what we're experiencing. How is that relevant to the logistic and the integration of industrial world with the logistic world? Is that we're having the same issues on logistic. We're having challenges to find personnel. We're having complex processes with high transport cost, so everything has to be optimized. Small batches as well, and requirements like traceability are becoming increasingly important. Quick, flexible logistics. So all this together creates a perfect environment for us to think of optimizing our manufacturing and our logistic processes. On this slide, we're showing a picture which is just an example of an industrial environment when you have a lot of different machines, some complex processes where planning and scheduling becomes a challenge, where you have different, it will go from one machine to another. And typically what it creates is that, delays in delivery of material, a lot of material standing around in your WIP processes because it's waiting to be processed. Unnecessary stocks of buffer, sequencing that's not perfectly done, and then you see on the inbound buffer that you will have requirement coming from your warehouse and your storage that are not sometimes perfectly in time with what has to be done in the industrial process side. So this is what we want to talk about. We want to see how we can get to the Industry 4.0, where we would have complete integration of the software. We would have complete integration of your processes between, again, your warehouse, whether it's a raw material storage or whether it's a finished goods storage, and all the WIP that you have in between, and your processes on the industrial side and the assembly side. Processes that we know, like a supermarket, Kanban, buffers, a frozen zone when it comes to planning, all this can be better managed by having the software and by having, more importantly, integration of the software. That's what we want to focus on today. Keeping in mind that the software is one thing, we can also optimize the layout. We can also bring the good to a person, but bring the good to the machine as well, in perfect sync with what has to be done on the planning side. In general, every company would have some kind of an ERP system, which would manage the business administration, manage the orders. That ERP will typically communicate with a WMS, which is a warehouse management system that would manage, like I said, storage inbound, outbound, but also in the WIP. And sometimes you have an MES, which is software that would manage your planning, your labor, all your equipment. The key is, how can we make sure that there is smooth interfaces built in and the communication between various softwares?
Okay, so in principle, you saw in the previous slide that the IT systems, ERP, WMS, and MES cover all information which you need to control a manufacturing company. But why these pain points appear, which Matthew mentioned, like, for example, delayed material, intransparent inventories in the production. So let's look a little bit deeper to the different IT systems. First, there's the ERP system. The ERP system is made for administrative tasks, so I do not have any knowledge about operating business on the shop floor. So, for example, concerning the production, the ERP knows exactly what must be produced and which quantities have to be produced. But the ERP system do not know exactly where it is produced because it do not know the machines and the topology in the shop floor. And the ERP also do not know the exact position of the material in the storage, because this is the responsibility of the WMS system, and also do not know the resources to transport material from place A to place B. And additionally, some companies are already using our MES. The MES knows much more about the production. So it knows exactly on which machine I produce which material. And it knows which quantities of a material is needed in the different machines. But on the other hand, the MES do not know exactly the information about the available inventories in the warehouse. This information is located in the WMS. The WMS knows everything about the single inventories, the situation in the warehouse, and the WMS knows all the transportation, material handling resources, and can control optimal material transport inside your plant. But the WMS do not know exactly which material is needed at which time, at which machine, and which quantity. So this is information which is, again, in the MES. So you see the problem appears because the information are available, but they are encapsulated inside the different IT systems. And that's why we think we have to establish a communication between the MES and the WMS. I will explain this on these slides. So here you can see an arrow. That's the arrow represents a typical material flow inside the plant. It starts at the receiving. The receiving is the responsibility of a WMS. So raw material arrives at your plant. You register the goods and store it in your warehouse. And when you start a production order, the WMS is responsible for the picking and the transportation of the material to the production area. So that's the receiving part. Then the responsibility of the WMS stops. It comes back again when the finished products are finished, and we take the products from the production area, store it in the warehouse, and if you sell it, we pack it, ship it. And in between the responsibilities of the WMS, there's the production side. Of course, maybe you also have some automation in the production side, for example, numerical controlled machines, but it's very typical that the production planning is still done manually by a person. So this person has a complex planning board. You can see here a picture which shows the planning board, and the person is assigning the different production steps to different machines. And so they are doing a planning, but this planning is quite complex because each machine has a different capacity, a different performance, etc. So it needs a lot of experience for the guy who is planning the production steps. This is a typical situation, for example, for a modern factory on the level industry 3.0. So you have automation, but you do not have any information link between the systems. You can improve a little bit the situation if you get rid of the planning board by a software like a MES system, manufacturing execution system. This software can plan the production much more efficient than if you do it manually. But we still have some problems with the material transport because here still the systems, as I mentioned before, has encapsulated information. So I can only bring the material to the production site, but not to the machines, not at the right time, not at the right quantity, because I do not have the exact planning data of the MES. So that's the next step of integration. If we make an IT interface between WMS, MES, then we have a horizontal integration, as it is, for example, for Industry 4.0 systems. Here we exchange exactly the data, the planning data to the WMS, so the WMS knows which machine needs which material at which time, at which location, and we can prepare out of the WMS all the transports to the machines. So we have a much better level of production supply. And additionally, if we have this communication interface, we are also able, for example, to manage work in process material, the WIP material. The WIP material is, the task is quite difficult to manage it because the ERP system do not know the part master of the WIP material. There is no part master. If you do not have a part master record, you can create an inventory record. The MES system can provide a WMS system a temporary part master record so that we can create and track also the VIP material. So that's a very big advantage. You have more transparency in your production site, and you have a more exact supply of your production. Let's have a look to the IT architecture and the communication. The interfaces between WMS and ERP and the interface between MES and ERP remains the same as before. The WMS receive orders, inbound orders, outbound orders, part master data, and confirm all activities back with transaction data. And the same for the MES. We still have the same interface. So the MES imports production orders and bill of materials and sends back status information. What's new? New is the horizontal communication. So the communication between MES and WMS is based on the information about material and tool requirements to supply the production, but also to remove the goods, the produced goods from the machines and transport it to the next station. And the confirmations are transaction data. Very important for such a setup is that you keep in mind the base principle. So the WMS is always responsible to manage the inventories and handle the material flow. And the MES is always responsible only for the production stuff. Here I have another scheme where we show the responsibilities. So as I told you, the WMS always responsible for everything which is connected with inventory management and transportation. Also, if you have warehouse zones very close to a production site or inside a production site, for example, like supermarkets or Kanban systems, this remains always at the responsibility of the WMS. And MES is responsible for the production, and the physical and logical interface are always inbound buffers and outbound buffers. Inbound buffers, outbound buffers are just storage locations near the machines where we supply the goods or we take it away from there.
So now we talked about the software, we talked about all the exchange of data between MES, ERP, WMS, so you can manage your operation much better. Let's talk about the physical move of the goods. It's one thing to have the software now that allows us to build a layout and potentially add automation to your operations, which is what we want to show right now. It would bring the speed, the reliability, traceability of every good, and it would bring not only, like I said earlier, the good to person, but also the good to the machine on time according to the machine planning. So I will show a video. And in that video, basically what we want to show is the fact that goods are coming in many forms to your operation. It can be a pallet, it can be cases, it can be totes, it can be any size, it can be any shape, any weight. Automation will be able to standardize that. As you can see on that video, we have a robot that's depalletizing those pallets coming from somewhere else, potentially from your storage, and bring those pallets into, or break those pallets into cases, space it, and then put it in trays, put it in totes, in whatever form that makes sense. I don't know if you think about your operation, those can be fasteners, it can be like nuts and bolts, so it can be parts of an assembly process, parts of your product itself. That would be automatically managed by the software and brought to the place where they should be. You can see in the back that we've got additional storage where those could be stored in order to create a buffer, to sequence it in the right order, and to be brought to the machines, which could be here on the side, or to be brought to the operator to be able to pick on time everything that's required. So now picture that you see this lady walking on their picking stations and building pallets, but she could be also feeding the machine, feeding your assembly process, your stamping machine, your molding machine, whatever process you have on time, using the components that are required to your process, and directly communicating with the MES so that we know exactly what's needed and we know that in advance so the good can be brought at the right time when it's required. That could be step one when we got the first operator, and then behind it you got step two, that could be a second machine, and then you got step three, and every time in between there would be a WIP, some kind of a storage buffer management, which can be brought back to the storage rack that you see on the left side. So now we'll go back to the slides. This was just an example to express, to explain how you guys can visualize what it would look like. Go back to the slides, and then we go back to you, Marcus.
Now I will show you an example how ERP, MES, and WMS is sharing a job. The ERP system has a production order. The production order to produce material SKU XYZ. So to produce XYZ, you need 4 raw materials, SKU1 till SKU4. This is sent to the MES system. Then the MES system is doing a detailed planning of the production. So the MES system exactly knows which machine can do what and which time, and then it makes a complete, detailed planning of the production and creates a new bill of materials sent to the WMS with all the inventory requirements and the cutoff time. The WMS now starts to pick the first 2 raw materials, SKU1 and SKU2, and move it to the production cell number 1. Production cell number 1 is working, and we create a VIP material, WIP material number 1. And additionally, we need at this time a new material, SKU3, from the warehouse, and move both to the production cell number 2. Here you have the whole transparency also about the SKU material WIP1, because we created an inventory record. Then in production cell number 2, you create the WIP material number 2, move it to production cell 3, and in production cell 3, you also put the SKU4 out of the warehouse in that moment when SKU WIP2 appears and the production cell 3 is working. And the result of production cell 3 is our material SKU XYZ, which we move to the warehouse. So how we can control this and manage this and supervise it at the control station. Here at WMS should provide monitoring screens. Here's an example where you can see in detail all the material requirements with the bill of material, the cutoff times, when you have to pick it, when it should be at the machine with all the milestones, and you have a detailed overview about the actual situation of the production supply and its statuses. And how this material transport can be done. So in the video, we saw conveyors, we saw HEVs or forklifts, but a very efficient thing is, for example, a milk run system. A milk run system consists of such a train, such a tucker train, which has a lot of wagons where you can store different load units for many different locations and warehouse and production orders. And the train moves along a road through your production site, stops at different production cells, assembly lines, whatever else, and supply the production locations with material and take off the finished goods or the WIP material to transport it to the next station. It's a very efficient way of production supply. Okay.
So when we go back to the WMS now, I mean, the key to all this is to make it simple, to make it flexible, to make it responsive to any change. We saw that on the MES side. We can see that on the WMS. So you can track all your order as you can see on that screen. You can track where they are, you can track the status, you can track where the product is physically anytime. And then, you know, the benefit of this is also that you get a bunch of KPIs that can be defined together in order to check efficiency, to check, you know, shipment, to trace it. So what we see on that screen on that kind of an iPad would be like an operator, a manager, someone being remote. It doesn't have to be on site, can be anywhere in the world, checking real time what the system looks like, what the orders look like. All those widgets that we can see on the screen can be, you know, defined to the needs of the operator or to the manager, to the level of the operators, because everyone has a username, and depending on the sign-in, it will change what you see. And again, make it like very flexible, very transparent, and accessible anywhere in the world. That's how we conclude our presentation. So thank you for the time. If you have any question, then we'll go to this next. Thank you.
Thank you very much.